Multiply with variables. Example 1. Multiply and reduce this fraction. So we have px over 10 multiplied by 20n over x squared. So let's go ahead and rewrite this. So we're going to go px over 10 times 20n, and then instead of x squared, we're going to go write x times x. And it'll make more sense in a minute. So when we go ahead and multiply, right, we multiply what's on the top, and then we multiply what's on the bottom together. So we could go about this two ways, right? We could go ahead and cancel if there's any terms that, right, like cross cancel here. So like this x here and this x here would cancel out each other because x over x, right, is just equal to 1. So if we were to multiply it out, we would have that, but we could just go ahead and reduce this before we even multiply. Then we have a 10 and a 20. So this 20 could be divided by a whole 10, and this 10 could be divided by a whole 10. So that would just become a 1, and this would just become a 2, right? And another way would be we could take out first a 2, so that would become a 5, and then that would become, right, a 10. And then we would further reduce that by taking out a 5 on both of them. So we just kind of went 2 times 5, right? So that was 10, so we could take out a whole 10 from both. So that's how we did that. And then that's all we could do. And now we can just go ahead and multiply. So we multiply what's on the top. So we have a 2. We're going to put the number first. 2, and then we'll do p n, and then over, well, there's no, we could put the 1 there, but we also don't even have to put the 1 there. It's understood that there's a 1, and then just over x. And that would be our solution. Now let me show you that what if you didn't want to reduce until after you've multiplied? But I'm still going to write x times x over here, just to show. Okay, so then we have 10. So let's go ahead and multiply. So we multiply what's on the top. So we have 20, and then I'm going to go pxn over 10, and then we just multiply x times x. So that's just, right, like this. And so really, right, this is also understood that all of these are being multiplied together, right? And so now we can go ahead and reduce. So we have a whole x here, so we'll take that out, and we'll take this out because, right, it cancels out because it's just equal to 1 then. Now we have a 20 and a 10. So let's go ahead and show. So let's take out a whole 2 here. So then that becomes a 10. 20 divided by 2 is 10. This 10 divided by 2 is then 5. And then we have a 10 and a 5, which that can be reduced. Divided by 5. So that would become a 2, and this becomes a 1. So what are we left with? We're left with 2pn over x. So we got to the same answer. It's just two different ways to get there. Now let's go ahead and do the next example. Example 2, we're going to multiply and reduce this fraction. So let's go ahead and rewrite this. And I'm always going to write out the exponents out rather than showing x squared. I'm going to go x times x, and then over 3, and then we're going to go 9 y over 8x. So let's go ahead and reduce before we even multiply. So we have an x here, so that crosses out this one. And then we have a 4, and we have an 8. So that can also be reduced, right, before we even multiply. So 4 divided by 4 is 1. 8 divided by 4 is 2. Then we have a 3 and a 9, and those can cancel out a little bit here. So 3 divided by 3 is 1. 9 divided by 3 is 3. So what are we left with? Well, we're left with 1x times 3y. So what do we get there? We get 3, because 3 times 1 is 3. And then we have x, y. And then we have 1 times 2, so that would be 2. And then that's it, right? There's no number, so it's just over 2. Now, also, when you input this into WAMAP, you're going to probably want to put this all in parentheses and this in parentheses with this division bar. It'll just make it easier. So you'll probably do something like this in the input. And this way is because if you didn't put the parentheses, with the 3xy, it would only show this y is probably over 2. It's just not always understood that the whole 3xy is on the whole top. So now let's go do the last example. So example 3, multiply, reduce this fraction. So let's go ahead and rewrite this. So we have 5x squared. So we're going to go 5 times x over 4a times 9. And then we have, you notice, 6 a's. All over 12x. Now let's go ahead and just multiply everything out, and then we'll reduce at the end. So we have 5 times 9, right? Because we're multiplying everything on the top. So we multiplied the numbers together. So what do we get? We get 45 then, and then we have x times x, and then we have 6 a's. And then on the bottom we have 4a times 12x. Well, 4 times 12 is going to be 48. And then we have a times x. So let's go ahead and take care of the variables, because that's pretty easy to see when it's all out. So we have an x on the top and we have an x on the bottom. So we can take out a whole x, because x over x is just equal to 1. So that's why it can cancel out, right? Because we're just saying this is being multiplied by 1. Then we have an a here and an a here. So that can cross out. So on the top we just have 1x and 5 a's. Now let's go ahead and look at the numbers, because we can reduce here. We have 45 and 48. So both can actually be divided by 3. So 45 divided by 3 is going to be 15. And if you need to go ahead and do this, say like right here, right? Now we know 45 can be divided by 3 because we add up the digits. Remember this, 4 plus 5, so that's 9 divided by 3, which comes out right to be 3. So we know we can. 3 can go into 45, 4 can go into 4 one time. You subtract, get 1, bring down the 5. 3 can go to 15 5 times. So we know 15 is there, and then 48 divided by 3 is just write one more like 3. So 3 times 16 then would be 48, right? If we were to do like multiples, right? So this would then just become 16 here. So let's go ahead and rewrite this. So we have 15 over 16, because that's as much as we can reduce it by. And we have 1x and we have 5a. So we'll just actually shorten it to having an exponent. So a to the 5th. And so this would be our solution.